We're back for our final conic section, hyperbolas. Well, there's a lot to talk about for these graphs. By the time we get to actually graphing them, you're going to think it's pretty easy. The big learning curve is learning what's going on in the graph of a hyperbola. First off, there is a vertically oriented hyperbola and a horizontally oriented hyperbola. There are also diagonal ones, but we are not going to focus on those at this time. Now, this is going to be weird, but when you have a hyperbola, there's a rectangle inside of there. So I'm going to draw that in. Now, it's kind of weird. Like, this makes more sense when you're working from the equation and you make the rectangle based on the equation. This is going to seem very random while I put it in. Notice how I'm doing it in dashed lines because it's really not part of the hyperbola. It's just how you graph it. Notice that the top and the bottom of the box here and the left and the right here touches the two vertices, the two vertexes of the hyperbola. So that's how I knew how long to make it. How wide do you make it? Depends on the equation. So if this is the center, now the center is going to be smack in the middle of the box. And I chose to put the center on the origin. It doesn't have to be. So the center is always right in the middle. And up here, this is your co-vertex. This is obviously a vertex. It looks like a vertex. This looks like a vertex. And this is weird, right? Those co-vertices are just hanging off in space. And that does not make a lot of sense. And I get that. I gotta show you the body parts, and then I gotta show you the equation, and then we'll pull it all together, and hopefully then it starts clicking a little bit. What you might need to do is watch this, record it, see a couple videos, and then go back to the beginning, and it should make more sense the second time through. Alright, so what are the things we're going to see in an equation? Excuse me. We're going to see an A in the equation. Oh, I wanted to switch to green. A is the distance, like in our last lesson, from the center to the vertex. That's the same. B is the distance from the center to the co-vertex. That's the same. And C, we're not even going to worry about. C is the distance from the center to the focus, but don't even worry about that. We'll just worry about A and B. What really messes with people in a hyperbola, A does not have to be bigger than B. I wish it was. I wish it was true like it's true for the ellipses. It would make it easier to teach and easier to learn. The problem is it's just not true. So while it's true when you're doing ellipse equations, A is always the bigger number. For a hyperbola, that is not true, so we got to look at it differently. So here's a picture. Here's something that's true. Now I'm going to erase the green and I'm going to write the equations. Then we're going to jump into our first examples. Equation, vertically oriented hyperbola. And horizontally oriented. Whoa. Huge difference. These are minuses. I want you to notice the similarities and the differences with the ellipse. It looks very, very similar. The big difference is that is a minus sign. If you see a minus sign, that is a hyperbola, not an ellipse. Furthermore, if you look carefully, for the ellipses, we kept the x in the first position and we flip-flopped these denominators. When we do the hyperbola, that's reversed. We leave the a and the b in those places. A always comes first. So for an ellipse, a is always bigger. For a hyperbola, for a hyperbola, a is always the first number under the fraction. Ellipse, biggest, hyperbola, first. So how do I tell? Like that was how I could tell an ellipse. For a hyperbola, if the y comes before the minus, it's vertically oriented. Y-axis, vertical axis, y first. If it's horizontally oriented, x-axis, horizontally oriented, x first. X before the minus. That is how you tell. Alright, those are the equations. Now we really got to see this. How do you put this into practice? There's all these weird parts. That box is just weird. Plus, I haven't even drawn in asymptotes. Technically, we need the box because there's asymptotes. It's okay that we didn't do them before because that really comes out. It really comes out when we're doing our problems. So let's just look at an example. We'll walk through another one, and then we'll see where we're at. Let's start with y minus 1 squared over 4 minus x plus 2 squared over 9 equals 1. Okay, this is all new. There's all this weird stuff going on. Let's try to deal with what I'm comfortable with. 1, I see a minus, I see fractions, hyperbola. 2, the y is coming before the minus. I'm putting this in nice simple terms. This is how to remember this stuff, in my opinion. The y is coming before the minus, vertically oriented. I've already understood that this is a vertically oriented hyperbola. It's going to look like that. 2, the center is going to obey the same properties as we did before. It feels exactly the same. X with the x, y is the y, switch the sign. See, that part is the same. In this case, if this was in the last unit, I might say a is 3, because a was the bigger number, but not true. A comes first, B comes second. So that's all my information. I'm ready to start graphing. Actually, I want a little more space for my graph, so I'm going to slide this information down here. So I can put my graph over here. This marker's running out of steam. Let me grab another one. Alright, so let's see what we have here. I know where the center is, so I'm going to do that first. Minus 2 up 1. There's a center. So maybe I should make a little algorithm. Make that all small. First, if I'm graphing these, plot the center. Second, make the box. So how do I make the box? So see how it's oriented up and down? So the vertexes will be up and down. So I got to go 2 units to this vertex and 2 units to that vertex. And then to the co-vertexes, so from the center, I'm going up and down 2 to the vertexes, and sideways 3 to the co-vertexes. So 1, 2, 3, 1, 2, 3. So I use those, use V1, V2, CV1, CV2. So it's like if this was an ellipse, see how it would make the ellipse? Well, now we're making a box. Just use, I gotta do this straightforward. Right, so instead of making an ellipse with those dots, I'm making the box with those dots. Third, we're going to draw the asymptotes. So I glossed over that earlier. What do you mean the asymptotes? Well, I know that the hyperbola is going to open like this, but it could open really broadly. It could be very narrow. So what the asymptotes do is they're kind of guidelines for how the hyperbola opens. And all you got to do is see these diagonal corners of the box. You just shoot a line out through the two diagonal corners. And then do the same thing here. It should also go through the center. Now all these these are called asymptotes, but all these lines do is allows you to put the hyperbola in and make it kind of normal looking. Fourth, draw the hyperbola. Well, it doesn't open left and right, it opens up and down. How does it open? I would start at the vertex, and you want to head towards this asymptote, and head towards this asymptote. So this is very flattened out. Head towards this asymptote. See, they're like coloring in the lines. Those asymptotes are guidelines, so I know how that this hyperbola opens. The hyperbola is the black here. This is the center, vertex 1, vertex 2, co-vertex 1 or 2, co-vertex the other one. Okay, so if you just reflect on what we just did, I see the numbers, y first, up and down. It was a minus, so it's a hyperbola. Center, we've been doing that for a few units now. A comes first, but it's the square root. B comes second. Then you got to transfer it to the graph. I get the center easy enough. The box is the weird thing. So you got to know how this opens. That's the A number. So I'm going to go up and down 2, left and right 3, and create the box. Draw dashed lines through the corners like that, and then that's what allows you to create your hyperbola. It's a lot of steps, but that's the only way to get it with a somewhat accurate shape. We better put fifth, label, center, vertices, co-vertices. Now there would technically be a focus inside of each of these dishes, if you want to put it that way, but we're not worried about the foci, however you want to pronounce it. We're just trying to get a hyperbola. So we need to do another example. Let's try a horizontally oriented one. And this time we'll make it a little narrower, or at least that's my goal. Okay. Let's do 4. Over 25 equals 1. All right, what do I know? I know it's a hyperbola. I see the fractions and the minus sign. Secondly, I know that because the x comes first, it opens sideways like that, horizontally oriented. Thirdly, I know where the center is. It's at -2, +2. Third, A comes first, so A is 2 and B is 5. So there's my raw data. Now what do I do with that data? This stuff. So I guess step 0 would be make a graph here. Your axes. First, plot the center. -2, 2. Second, make the box. All right, A is how far to go to your vertexes. See how it opens? Left and right. So I need to go left 2, right 2. And then your co-vertex, it's got to be 5 the other direction. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Shoot, this is going to open wide again. Oh well, I want to do a narrowly opening one, but it is what it is. Instead of making an ellipse, I make a box with these points. Using the vertices and the co-vertices. What do I do next? Draw the asymptotes. How do you do that? See these diagonal corners? Then I draw in the actual hyperbola. This is all just the setup, believe it or not. So how does it open again? It opens left and right. So from this dot, I'm going to shoot towards the axis. This is totally the opposite of what I want to do, but it'll work. And then over here, I got to do the same thing. And then the last thing I got to do is label stuff. Center is in the middle. This would be vertex 1 and vertex 2. Co-vertex 1, co-vertex 2. Remember, the vertices are actually on the hyperbola, the dishes, the curved parts. All right, let's try one more example. Alright, so this one looks different. It is a hyperbola because I see fractions with a minus. It is horizontally oriented because the x comes first. The center is at 0, 0, right? X minus 0 squared, y minus 0 squared. A comes first, so it's 6. B comes second, so it's 2. There's my information extracted from the equation. Now I have to put this onto a coordinate axis. Actually, I'm going to scoot this over a little bit. First, plot the center. 0, 0, no problem. Second, make the box. Okay, how does it open? Left and right. So I got to go 6 left and 6 right. 5, 6. 1, 2, 3, 4, 5, 6. And then I got to go 2 up and down in this case. If this was an ellipse, I could draw the ellipse, but it's not. It's a hyperbola. So I'm going to use these dots to form a rectangle instead. What do I need the rectangle for? To draw the asymptotes. And what are the asymptotes for? So I can properly draw the curves in place. So I need the space. That's okay, because it's our last example here. So the last step we do is, I remember this opens left and right, so I'm going to start here and head towards that asymptote. There we go. So this one's opening a little more narrowly. And that would be my hyperbola there. So I've cut out a little bit out of all these units. We haven't graphed the foci, but this is by far the bulk of the material. So if you get all this business, You're in very good shape. Remember, you can send me emails with questions or comments onto this video, and I will get back to you. Be sure to practice, and we'll gear up for the test. Take care.